let's give this another try. So this video is going to be about how to do conservation of momentum problems. So um, all these equations are the same thing. They're just describing the same thing in different ways. Basically, different levels of specificity. But they're all set up the exact same way. The left side of all of these equations is describing what happens before the collision. So everything on the left is describing before. Everything on the right side is describing what happens after a collision. And the idea is all the momentum that happens, or all the momentum added up going into a collision is the same as the total momentum coming out of a collision. Because the idea behind the conservation of momentum is that momentum cannot be created or destroyed, only transferred between objects. So maybe, for example, object 1 will get some of object 2's momentum, but overall, the total amount of momentum doesn't change, just transfers between objects. That's all. And the last thing I want to say is that these things, these apostrophes, they're called prime or primes as like plural. All of them are primes, but a single one is a prime. And all that does is it just says that the thing is attached to, so this one here is attached to momentum. It's saying that this momentum happens after an event. So we're talking about collisions right now. So the only event we're talking about is collisions. So when you see a prime, it just means that whatever it's attached to happens after the collision. So this is the equation that we're going to be working with today. Next week we'll get into these two, but for now we're just going to ignore them. The reason we're focusing on this one first is because, as you can see, there's less parts to it. These ones here have lots of parts, and so we need to get used to the organization and using lots of equations, or lots of variables rather, because otherwise if I just threw these ones at you, it's a mess. And kids get it all disorganized and it's very confusing. So we need to practice the organization before we get into the more complex ones. All right, so let's look at some practice problems. I'm going to give you two basic types. One where the two things spread apart, and one where the things stick together after the collision. And those are the two main types of collisions anyway, so that works out. Okay, so while we go through, I'll be highlighting things because that's the way I like to break down text. When I'm working on paper and pencil, I'll just underline or circle things that I think are important. But because I can highlight and easily switch between things on the computer, it's nice to do that. So a car is traveling with 650 kgm over s of momentum when it hits a rogue shopping cart traveling with negative 100 kgm over s of momentum. After the collision, the car has, okay, so I just saw the phrase after the collision. When you see after the collision, that's a pretty good indication that you should, or you can, break the question in half right there. So everything, like just make a line, everything above that line, everything above is before the collision, and everything below the line is after. Okay, so that way you can, it's just a helpful way if like looking at a block of text is overwhelming and you're like, I don't know how to break it down. This is one way to at least cleave it in half so you're only looking at smaller chunks. Okay. So after the collision, the car has 400 kilometers times meters per second. momentum. What is the shopping cart's momentum after the collision? Okay. Okay. So step one, we need to draw out the situation and label the parts. All right. So we have a car. I'm going to draw a box and label it C for car. It has a positive momentum. And the reason I like to highlight things also is just that way I don't even have to reread the whole problem. I just go back and I see, okay, this I highlighted, what is this about? It's about a car. Okay, so that's where I got the C. And I'm going to draw an arrow to the right because this is a positive momentum. If you guys remember, in physics, positive means to the right or up, and negative means down or to the left. Since cars don't typically go straight up in the air, I can assume that it's probably reasonable that it's going to the right. So that's where the car gets the right arrow from. Additionally, the shopping cart. So there's a shopping cart, so I'm going to draw a box with an S for shopping cart. It has a negative momentum, so I'm going to draw an arrow to the left. Okay, and then a collision happens, so I'll draw a line. After this collision, so below, the car has 400, so the car has 400 kgm over s, so that's positive, so it's going to the right. And the shopping cart is what we need to figure out. We need to figure out its momentum. It doesn't tell us whether it's going to the right or to the left. So I'm just going to put it here. I'm not going to give it an arrow. I don't know what's going on with it right now. That's what we need to figure out. So now let's go through and label all these parts with the information from the problems. That way we don't have to keep looking at the problem for info. Okay, so 650, that goes with the car before the collision. Okay, so go over to the car before the collision, put PC, because P is in momentum, C is in car. Momentum of car is equal to 650 kgm over s. Momentum of shopping cart is negative 100, so PS equals negative 100 kgm over s. And then after the collision, we have the car going with 400. So you notice I put PC prime. Remember, prime is means after. So PC is momentum car after. Momentum car after. PC prime. Momentum car after. Momentum of car after is equal to 400 kgm over s. And then shopping cart PS prime. Momentum shopping cart after is unknown, so it just gets a question mark. Cool. So now we don't even have to look at the text anymore. All the information we need is right here. Step 2 is let's figure out our equation. So our base equation is P1 plus P2 equals P1 prime plus P2 prime. Let me rewrite this right side of the equation. It's supposed to be red because it's after the collision. P1 prime plus P2 prime. Okay. So now what I want to do is change these 1s and 2s to the symbols that we're using in the problem. In the problem, we're using C and S for shopping cart and for car. So we'll just change 1 and 2 to fit what we're actually doing in the problem. PC plus PS is equal to PC prime plus PS prime. Okay, so there we go. Now we know exactly where to put everything. We have everything set up. So now we are ready to just go to step 3, which is plug in our numbers and solve. All right, so PC we have listed as 650 kgm over s, easy. PS is negative 100 kgm over s. and PC prime is 400 kgm over s plus, oh, biscuits, that needs to be red, plus PS prime. Okay. So I'm looking at this. The first thing I want to do is just simplify the left side of the equation. I can add these two together. I don't have to do anything fancy. 650 minus 100 is 550 kgm over s. And then I'm just going to bring down the right side of the equation as well. Nothing changed over here. But the problem's a little bit simpler to tackle if you just simplify. Okay, so we need to get PS prime, momentum shopping cart, after by itself. So let's do the opposite function. Currently it's addition, so the opposite would be subtraction, and let's get rid of the thing that is not what we're looking for. Okay, what you do to one side, you have to do to the other. Okay. This zeroes out because 400 minus 400 is 0. So that leaves PS prime by itself on the right side of the equation. And 550 minus 400 leaves you with 150 kgm over s. And there we go. Nice. Okay. So that's pretty simple. The most important thing really is just getting this down. Understanding how to diagram and label everything correctly. That's what's going to make or break, especially when we get into the more complex problems, because they have 7 or 8 different components versus this only has 4. So if you get in the habit of being able to label and recognizing that each part is like referring to a specific object, like P1 always refers to this, P1 prime refers to this thing. If you understand that, then you're not going to have any problems when we get into the more complex stuff, if you can perfect the organization now. All right, so let's look at a different type of problem, one that has the objects sticking together. Okay. So we have a dog, and this dog is sticking its head out of the window, but the dog has doggles, which is just goggles for dogs. And here's a picture of a dog with doggles. So we do not know how fast the dog is going, but we do know that there is a beetle flying with negative momentum, negative negative 0.045 kilogram meters per second. Sorry. Okay. There we go. Okay. And then it collides with the doggles. Everything up here, there's nothing important in there. It doesn't tell us any numbers or anything. After the collision, okay, so there's that phrase after, or the word after. So I'm going to draw my line. Okay. So everything above is before, and everything below is after. Okay. After the collision, the beetle splatters on the doggles and together. So that's interesting. So I'm going to highlight that. Together, all of these things travel with 65.955 kilogram meters per second. What was the initial momentum of the dog? Okay, so the question is asking about the initial momentum of the dog. All right, so let's put this together in a drawing. So I already have a picture of a dog with doggles written here. At no point does it tell us what the momentum of the dog was. It doesn't tell us what direction it's going. I have an idea of where it's going based on the final momentum. So like I can read that and I understand that because this is positive, it probably means that the dog was already going to the right. But I don't know for sure yet. I got to run the numbers to test that hypothesis. But for right now, I'm not going to do anything. I'm just going to let the dog sit. But I do know that there is a beetle, and this beetle is traveling to the left. And I know that because its momentum is negative. And then afterwards, I know that the beetle splatters on the dog's face, and together, so I'll draw the bug's guts in green on the dog's goggles, not on its actual eye. Thank goodness that dog had goggles. And together, the momentum of the dog and the momentum of the beetle are moving to the right. Okay, so I highlighted this in green just to show that if you just to highlight, just to emphasize the point that if you ever see a phrase that says like they stick together or they move together after a collision, that you should do something like this, where you treat them as if they are one object. And that's what I always like to do. I like to put them in parentheses to really emphasize the fact that that their momentum is connected. They are physically like objects tethered together now, and so we're going to treat them as one object. So just put them together because they are together now. So let's go through and label these parts. So the momentum of the dog, well, we don't know what that is, so that's unknown. The momentum of the beetle, we know to be negative 0.045 kgm over s. Okay. And after the collision, we know that altogether, the dog plus doggles plus beetle travel to the right because it's positive. And together, that momentum is 65.955 kgm over s. Okay. All right, cool. So that's all I can get out of the problem. And now let's set up our equation. The base equation is P1 plus P2 equals P1 prime plus P2 prime. All right, so let's change that to fit our situation. So instead of P1, I'm going to use PD, as in momentum of dog plus momentum of beetle is equal to the momentum of dog after the collision plus the momentum of beetle after the collision. You don't have to write these two things in parentheses. It'll work out mathematically the same way. But I do that because I'm treating them as if they are one object. So putting them in parentheses will just, it makes that more clear. But in this context, in this actual, in this equation, it doesn't matter. In other equations, it does, but in this one, it does not matter. But it's just a good habit to get into. All right, so let's plug in our numbers and solve. All right, so PD, momentum of dog, we don't know what that is, so we can't change it into anything, so it stays the way it is. Momentum of beetle is negative 0.045 kgm over s. And all that is equal to the combined momentum of the dog and beetle, which is 65.955. Okay. So to get momentum of dog by itself, we need to get rid of this number. To do that, well, it's a negative number, so I'm going to add, because that will cancel it out. And I'm going to add it to both sides. All right, so this zeroes out, leaving momentum of dog by itself. And if you add these two things up, it gives you 66, which is a very satisfying number because it's an even number. It's nice and clean. And there you go. And that is how you do science.